All right, so we left off after completing, I believe, the dot plot. Let's see, we're going to find that out in a hot second here. The stem plot is the most complicated one. So it's understandable if you need a second or even a third look at this one. The box plot is probably, well, it's definitely not as complicated as the stem plot, but it's the second most complicated one, probably. The histogram is the easiest one. All right, so we'll start off fast here. We'll do the histogram first, then we'll do the stem plot, and we'll see where we're at. For a histogram, very straightforward. Copy the data. All right, just the data, no column headings, nothing like that. And then go to Insert, Chart. All right, so you copy the data, go to Insert, Chart. And most of the time, not all the time, but I'd say a good 90% of the time, the chart that comes up will be a histogram. All right. Oh, it's like it read my mind. It's that it understands that you have a certain type of data and that this is probably what you want as a display. And that makes sense. All right. But the thing is, yeah, it picked out the right histogram. I'm sorry, the right chart, which is the histogram, but it didn't really do it in a way that I would have liked, because we want the horizontal axis to say age of inauguration, which is perfect. The vertical axis needs to say frequency. It's a frequency histogram. All right, so let's do that. And if we want to customize our graph, we go to, you guessed it, customize. All right, now, if you're ever in doubt, you go right down each one of the drop downs and see which one is the one that has the stuff you're looking for. All right, but it's pretty clear that I want to change my title, so I'll go to the one that has the word titles in it. Chart title, and I remember the first time I was using this, I was like, okay, I'm going to go down the list. Where's horizontal axis? Where's vertical axis? It's in this drop down. All right. So you go to horizontal axis title if you want to change this one. We don't. You go to vertical axis title if we want to change this one. You could also click. You see how a little rectangle appears? If you click in here, it usually brings you right to the place to make an edit. Right. So that's good. Now, I want this to say frequency. Let me pick a device and I'll start writing here. I guess I'm writing here, frequency. All right, and as I type it, it populates, so that's good. And yeah, it says my connection's lost. This is not good. My keyboard, I think I overcharged it. So it's actually pretty good right now, but I also don't really like the labels on the bottom here. All right, so like I said, if you click on certain fields, the rectangle here, you could change the scale. The rectangle here, you could change the title. But if you're not sure, just go into the customize menu and just start clicking around. All right, if I go into histogram, you'll see an option that says bucket size. Buckets and bins mean the same thing. All right, bins, intervals, buckets, they all mean the same thing. And that is, how much numerically do you want to go from or for each bar in terms of horizontal axis. This is auto, which means you're letting the computer decide. I don't want to let the computer decide. I think intervals of distance 10 seem to make sense. So I'm just going to go down the line here, pick out a 10. And now you see it goes from 40 to 50. It's really 40 to less than 50, then 50 to less than 60, and so on. But it gives us a good visual representation of what's going on. If you think maybe there's too few bars now, change your bucket size to 5, go every 5 years. That also seems to make sense. And now you have a nice display. And just thinking back to what we were doing before, you may have to determine if you're looking at a symmetric distribution. This one looks almost normal. It's got a little bit of a skew to the right, right? Just over here, a couple of older presidents. But most of the presidents seem to be normally distributed, and we could verify this by using the empirical rule, not in this activity, but it's something that you could look at and say, hey, I wonder if this is a normal distribution. I wonder if that's how ages of presidents tend to break out or break down over the course of hundreds of years, right? So that's our histogram graph. That's the easy one. The stem plot's more challenging, right? So we're going to tackle that now, and if we have time, then we'll get into the box plot. So first thing I need to do is find the minimum and the maximum. So I'm going to type in min here, and I'm going to type in max here. Now, this is a relatively small set of data. So I could easily figure out that the 35 is the minimum and the 77 is the maximum. But if I have hundreds of data values, I don't want to have to worry about that, right? So I'm going to use a command, and that command is equals min. Anytime you're doing a mathematical computation, start it with an equal sign. You type in min, and then highlight the relevant data, all right? You can close the parentheses or not, it doesn't make a difference, right? If you close the parentheses or just hit enter, it's still gonna do the thing, you know, because you're not following that command up with anything else, right? It does ask you if you wanna do an autofill. That's if you believe that it's doing the thing that you want it to do. Here it's not. The biggest number is 77, so there's no way this is right. So I'll X that out. So I'm gonna go equals maximum, same data set. Now you see the column reference here is M, so it's in the column M, and it goes from 3 to 16. You could type in M3 colon M16 instead of actually dragging, right? Benefit of doing something like that, not so much right here, but if I needed to copy and paste from one cell to another, I can do that, all right? So I have the maximum value. Now I want to create a column that says stem and another column that says leaf. All right, stems, leaves, but either way, it's fine, right? So what we want to do here is indicate every possible stem between the minimum and the maximum, all right? And you could do that using a formula, but these numbers are pretty easy. So the stems are just the tens place for each of these digits. You know, so you look at 35, you have a left digit and a right digit. The left digit is the stem, the right digit is the leaf. All right. Now, if I had a 4-digit number, I'd have a choice. I could make the 1 the stem and 425 the leaf. All right. I could make 14 the stem and 25 the leaf. I could make 142 the stem and 5 the leaf. All right. You're splitting the number by the digits. It's very easy when they're only 2-digit numbers because it's right down the middle. All right. So that was just a quick example. But the stems here are going to go from 3 to 7, 3, 4, 5, 6, and 7. All right. Now for the fun part. So finding the leaves requires, if you're doing it in Excel, a special command, and that command is known as repeat. All right. So we're going to use the repeat command. It's REPT. It will, I'll just make a little note here, repeats. So rept, put that in quotes, repeats values a specified number of times. All right. So what I want to have happen is, let's say we have the number, I just took my glasses off, now I can't see. We have the number 68 occurs twice. I want the number 8 to show up in the leaf column for the row of 6. So I essentially want this to say 8, 8. all right, because 68 and 68 occur in the data set, 2 of those 68s. But I want this to happen for me automatically, all right? I don't want to have to type it in because, again, I always, whenever you're doing a graph or a computation, you always got to have an eye on the big picture where, okay, yeah, maybe you're only working with 20 values, but you could easily be working with 20,000 values, all right? So we want to make sure we have a technique that's going to work for the large stuff as well as the small stuff, all right? So the way we do that is starting with the repeat function, and I'm going to expand my my little bar here because it's going to be a long little script there. But I'm going to type in equals rept. I accidentally doubled the R. I rolled the R. I want to repeat the number 0. The thing that you want to repeat, that's the value. It goes in quotes. And I want to repeat that a certain number of times. Now, in the case of the 30s, if you're just looking at the data set, there's only one number here in the 30s, and it's not a 30. So there's really no need to repeat the number 0 any more than 0 times, all right? But I want to have that command in there in case in the future I'm working with a data set that does include a 30, all right? So what I'm going to do is I'm going to throw in a count if. So the command count if, right? Special command that will count up the number of items in a list that satisfy certain criteria. I'll write that down in a second, all right? So count if, open parentheses. I'll just leave that for a minute. I can't leave that for a minute. I'll type out the notes in a couple minutes because every time I click in a cell, it's going to want to put that cell into the line. All right. So I want to count if this data set here contains any 30s, just the number 30. All right. So the way I can build the number 30 is by taking what I have here, my first stem value, because, you know, like the next time you do a problem like this, maybe the first stem value is a 5. So you don't want to just say 30 because that it might not be relevant. But if I take this value that's in P6, multiply it by 10, that makes it a 30. Right? So now it's the number 30. And if I change and I can close it up real quick. Close that out. So I have my command in here. It'll put a 0 if there's a 30 in this list. There is no 30 in this list, so it's not going to put a 0 there. All right, but look, if I change this number to a 4, now it put a 0 here because there is a 40 in the list. All right, so it's flexible enough to handle any changes in the stems. All right, so I'm going to change that back. Now, what I want to do here, and it's tedious, but I want to repeat this command for every value between 0 and 9. All right. Fortunately, copy paste exists, so that'll help. But let me just put the notes here real quick. So count if. All right. What that does is it counts the number of values meeting certain criteria. All right. So what I can do is I just highlight everything, not the equal sign, but everything from rept to the end, copy that. So Command C copies, Control C if you're on a PC. Then I'm going to throw an and symbol in here. And creates a conjunction between two rules. So I want what I have here and what I'm about to put in there to satisfy this criteria or to determine the values of the leaves for the stems. So I'm going to do Command V to paste it in, and I'm going to change the 0s to 1s, and there's only 1 0. But then I want this part, the P6 times 10. Again, P6 is here, multiplied by 10, that's 30. I want to count if this is a 31. All right, so I want the ones to come into this cell if this entry is 31. Very easy way to make that adjustment, just add 1 onto the end. All right, so then I'm going to do it again, because now if any 31s show up in my list, and I'm gonna, this code will be available to you so you can peruse it later, but if any 31s show up in my list, it'll put a 1 in the leaf column. If there's 10 of them, it'll put 10 ones. All right, so and repeat it again, but this time looking for 32s. So 2 in quotes plus 2 at the end. And paste it again. I'm looking for a 33. So 3 in the quotes, 3 at the end. Now you start to see why I expanded the bar here. You know, give yourself more room. All right. And now we're up to 4. So put in a 4, add a 4. And put in a 5, add a 5. Now, one thought you might be having is, wait, we're gonna have to do this for 4, 5, 6, and 7 in a minute? No, we're writing it this way so that we could just copy and paste it. Then
That
once we're done with
the
this.
and sorry, Professor, the and sign didn't go through, by the way.
Oh, thank you. That's a big one. I appreciate that. All right. Okay, so now we're up to 6. Yep, Command V. 6 goes in here. Add a 6 on at the end. Just 3 more. So we need the and V 7 plus 7 and 8 with a plus 8. Home stretch and 9 with a plus 9. Now, based off of the list of data, the only number that should show up in this new cell should be a 5, because there's only one number in the 30s, and it's 35. So I'm going to hit enter, moment of truth. 5 showed up. It worked. All right, now what we can do here, grab this little bad boy, or you do copy paste if you want, but grab this little bad boy and slide it right on down the line. And now you have your stem plot. All right, because the 40s have a 0, 3, and a 9, boom. The 50s have a 1, 4, 7, and a couple of 8s, just how we see it here, 4, 8, 8, and a 5, 7. And so now we have the stem plot. And we had to do that bit of work first, initially, but then it paid off big time down the line. Because if you imagine if you had 1,000 values to have a graph that could be populated like this, very, very useful. The one last thing that you need to have for any kind of stem plot is a key. And all a key is a quick example of what the values in your stem plot mean. All right. Because when you're presented with a statistical analysis, you're almost never given the raw data. You're given a graph and some conclusions. You want to give the person a way of interpreting the graph. All right. So I'm going to type in 3 vertical slash 5 just to tell the reader that that means 35. All right. And I'm just going to highlight this because this is actually the entire solution. All right. But when you submit your work, I need to see the commands. All right. Because what I need to be able to do is change a few values in your set. Let's say I make these all 77s. Oops, not 7, but 77. And your graph should change accordingly. We want a graph that will be flexible enough to work with multiple data sets. All right. So I think, so I'm going to stop the recording. I think that's